just make sure to recognize in some cases you can see that both of these have the cosine squared of x. So if you factor that out, we would end up with cosine squared of x times 1 plus tangent squared of x. And then from here, you would probably use a Pythagorean identity, and the reason why I would use a Pythagorean identity is because try to recognize that when you see any trig function squared, like sine, cosine, or tangent, it may be a Pythagorean theorem, especially if you see that plus 1 somewhere in there. It doesn't necessarily have to be there. The one I tell you to memorize is this one, cosine squared x plus sine squared x is equal to 1, or sine squared x plus cosine squared is equal to 1. Now, if you see tangents and you want to, let's say you forgot the Pythagorean identity associated with tangent, try to get tangent. I know tangent is associated with sine over cosine. So if I see a sine here, I'm going to divide this one by cosine squared of x. But whatever I do to maintain equality to one of these terms, I have to do it to all of them. Cosine squared divided by cosine squared. This divides out to 1. Sine over cosine again was tangent because I wanted to reproduce the trig identity that has tangent. And then 1 over cosine, again, you should have this already memorized, is secant squared of x. And then right here you can see that all of this is the same thing as secant squared of x. So that's what I want to substitute here. All of this is going to become secant squared of x. And since I have a cosine and I have a secant, simplifying, remember, is trying to make things simpler to try to cancel out as much as you can. So on this example, what I'm going to do is I'm going to rewrite it. I know I had it before as 1 over cosine squared. So I'm going to write it out as 1 over cosine squared of x. And again, the reason I did that is because what's going to happen with the cosine squares? Yeah, they're going to divide out. So my final answer is just going to be 1. Now, for this one, you could have done it a different approach. Let me do that without, let's say, factoring out the common term. And like I mentioned, it all depends on the type of problem, and the more practice you have at these, which approach you take. Let me rewrite the problem. It's going to be different. Some of you may take a different approach. Some approaches take longer. Some approaches, are very short. But on this different approach, what I'm going to do is, I had mentioned that tangent of x was, again, sine of x over cosine of x. Well, somebody might say, well, let me start off with replacing that tangent. Cosine squared of x plus cosine squared of x times, instead of tangent, I'm going to rewrite it as sine squared of x over cosine squared of x. Now here, what do you notice about the cosine squares on this term right here? Yeah, they'll also cancel each other out. What are you left with? Cosine squared of x plus sine squared of x, and this is a Pythagorean identity where if I ever see cosine squared of x and sine squared of x, all of that is just equal to 1. Now, as far as, which approach do you take, like I said, it just depends on the problem, depends also on, practice. The more you practice these, the more you recognize which approach to take. So just be careful with those.